This is a resting neuron. It has a positive charge on the outside of its membrane and a negative charge on the inside of its membrane. The difference between these two is called the membrane potential, and a resting neuron has a membrane potential of negative 70 millivolts. This is also called the resting potential. The resting potential is maintained by the sodium-potassium pump, because as sodium enters the neuron and potassium leaves the neuron, the sodium-potassium pump will actually pump the sodium outside and pump the potassium back in order to maintain this resting potential. Now, if the neuron is stimulated by temperature or pressure or light or something of that nature, it will change the membrane potential. So if the membrane potential becomes less negative as a result of the stimulation, it is depolarized. If a neuron is depolarized to the point that it reaches negative 55 millivolts, this is called the threshold. Once it reaches the threshold, the action potential occurs. Once the action potential occurs, sodium channels are opened, allowing sodium to enter the neuron. Now this will change the charge of the neuron so that the inside of the membrane will have a positive charge and the outside will now have a negative charge. The inside of the membrane, or rather, the membrane potential can reach 30 millivolts or more. This is the peak of the action potential. At this point, the sodium channel will close and the potassium channel will open, allowing potassium out. This is called repolarization, which will eventually return the membrane potential to the resting potential. And the potassium channels will close. This will make the outside of the neuron positive again, and the inside negative. The action potential will activate parts of the membrane all the way along the axon until it reaches the terminals.